Hello, today we are doing lesson 6.6, which is solving absolute value inequalities, meaning we have the less than or greater than symbols. We did the exact same thing on 6.5, but instead of inequality, it was equal, or equality, or equation. So it says, recall that the absolute value of x equals 3 means that the distance between x and 0 is 3. The inequality absolute value of x is less than 3 means that the distance between x and 0 is somewhere less than 3. And absolute value of x is greater than 3 means that the distance between x and 0 is greater than 3. So the graphs of these two are shown below. So with less than, well, what we could put in here, we could put in a -3 or a +3. Whatever comes out, the distance between those numbers and 0 is less than 3. Over here, same thing, but the distance is greater than 3. There's no equal to, so this one, these are both open circles. Greater than 3, so the distance between 4 and 0 is 4, which is greater than 3. So one way to be able to tell these two apart, so you know how our graphs are going to look right away, is to simply look at this symbol. If you have the absolute value all by itself and you have a less than symbol, I like to think of less than, same right here, less than is for and. Having the same two letters, less than is for and, meaning our arrows are going to be pointing together, which they are right here, pointing in. And then greater has ER, but we say it like an O sometimes. Greater is or, meaning our arrows are pointing apart. So that's one easy way to tell which way our arrows will be pointing. So let's solve this inequality and graph our solution. So just like before, this could be a -6 or a +6. So we could have two equations. One, just like it is, x is greater than or equal to 6. Or we need one set equal to the negative. But be careful, key note here. If you are setting it equal to a negative number, you must flip the sign, meaning your less than or greater than sign. Okay? So right here, if we're going to have the -6, we have to flip our sign the other direction. So we have the negative and we have the positive. The reason why I put the negative over here is because when I graph them on my number line, the -6 is the least. I can just graph it right above where those numbers already are. So this is a closed circle at -6, closed circle at +6. And if you want to look at the symbol, it's greater, meaning it's going to be or pointing apart, which is exactly what it shows here. Less than -6 would be to the left, and greater than +6 would be to the right. So let's look at the other one here. We already have the absolute value by itself, so we can write two equations. One, just like it is, x is less than or equal to 0.5. Or we could also put in here a -0.5. So if we're going to set it equal to a negative, we have to flip our symbol, and there's x. So graphing these both on a number line, I put the negative on this side because it matches up right away. These are both closed circles. And greater than here is to the right, less than here is to the left. And if you wanted to double check, this is a less than, and we have an and symbol pointing together. So now we're going to go ahead and solve some. Same way we did with equations. Anything that goes in here has to be equal to +8 or -8. So let's write this 2 times. We have x plus 3 is less than 8, just like it is. And we also have x plus 3, and we want to set it equal to a -8. But if we're going to do that, we have to flip our symbol the other direction. Just like when we divide by a negative, it's like making it a negative, you flip the symbol. So we're going to solve these just like we would normal equations or inequalities. Subtract 3. We have x is greater than, these are all negatives, a negative 11. And over here, subtract 3 as well. We get x is less than 5. So on our number line, negative 11 is the least, 5 is the greatest. So these are both open circles. At greater than negative 11, well, positive numbers are greater towards the right, and like an L, less than 5 would be to the left. Same thing over here. We could set this whole thing, whatever goes in here, could be equal to 7 or negative 7. So we need to set whatever is there equal to both of those numbers. So I always write the one that has the positive number on this side, so when I graph it, the positive number is on the right. So I have 10 minus x is greater than 7. I put the line through the 7 so it doesn't look like a greater than symbol. And then over here as well, 10 minus x. And we need, instead of 7, we want negative 7, so we have to flip our symbol. So solving these, be careful now, this isn't a negative 10, it's a positive 10. The negative goes with the x, that's negative 1x. So moving this 10, we have to subtract 10. We have negative 1x is less than a negative 17. And then be careful, the opposite of multiplying is divide by negative 1. Whenever we multiply or divide by a negative, we have to flip, flip our inequality. So we have x is greater than now a positive 17. And over here, same thing, subtract 10. We have negative 1x is greater than a negative 3. Same thing, this is multiplied, we need to divide by a negative 1. That flips our symbol the other direction. Negative 3 divided by negative 1 is a positive 3. So on my number line, be careful now, when we divided by a negative, we flipped our sign, so we actually made these on the wrong sides as well. So 3 here is the least and 17 is the greatest, so be careful when you're graphing these. At 17, this is an open circle on that one right there, and pointing to the right, greater than. At 3, also an open circle, but pointing to the left, less than. That's an or statement, because it's one side or the other, just like we started off with a greater symbol. This one we started off with less than, and it's an and. All right. Same thing here. This could be equal to or greater than positive 17 or negative 17. So we have 2x minus 5 is greater than 17, and 2x minus 5, flip the sign, and negative 17. So solving this, first get rid of addition and subtraction. Add 5. We have 2x. There are more negatives, so negative 17 plus 5 should give us a negative 12. And then divide by 2. X should equal, oops, what happened to the equal? It's not equal. It should be a less than symbol there, a negative 6. And over here, same thing, add 5. So we have 2x is greater than, these are all positives, that gives us 22. And then divide by 2. X is greater than 11. So on my number line, negative 6 is the least, 11 is the greatest. So these are both open circles. At negative 6, we have an L for less than, it's pointing to the left. And over here, we have greater than, pointing to the right. I would like for you to try this one on your own and then click play to see if you got it correct. So I'm going to start by writing my two inequalities. 8 minus 3x is less than 14. And on the other side, 8 minus 3x, that part doesn't change, only this, and a negative 14. So draw your lines down. We need to solve both. First, get rid of just your number, so subtract 8. We have negative 3x greater than, these are all negatives, so 14 and 8 more should give us negative 22. Messed up there, not 24, 22. And then divide by negative 3 on both sides. Whenever you multiply or divide by a negative, our sign flips. So we have x is less than, two negatives here make a positive, and I have 22 divided by 3, which is going to give me 7.3. 7.3 repeating, or 7 1/3. On the other side, same thing, subtract 8. We get negative 3x is less than, this gives me 6. And then same thing, divide by negative 3. We have to flip our symbol. We get x, and that gives me a negative 2. So again, be careful when you graph this one. Wow, I'm impressed. That was a really straight line. Negative 2 is the least over here. 7.3 would be the greatest. At negative 2, we have an open circle pointing to the right. And at 7.3, also an open circle, but pointing to the left. And if you're not sure, this is a less than, meaning we have and. And we do, they're pointing together. Now we have to clean up our bathroom just a little bit. What I mean by that is we got to get our absolute value or our shower door all by itself, so we can set it equal to the negative and to the positive. So first we got to get rid of this 3. We have to subtract 3 on both sides. And we're left with 6 here. And then also underneath here we have the absolute value of negative 4x minus 5. I made my absolute value lines look fixed so that I know it's not just a 1. So now that I have my absolute value by itself, write two equations, one with the positive and one with the negative. Negative 4x minus 5 is less than 6, and negative 4x minus 5, we want a negative 6, so we need to flip our sign. So let's solve both. First I'm going to add 5 to both sides, get rid of addition and subtraction. We have negative 4x, and negative 6 plus 5, there's more negatives, there's one more. And then last, the opposite of multiplying is divide by negative 4. Whenever you multiply or divide by a negative, flip your inequality symbol. So if x is less than, now a positive 1/4, or you can put 0.25 if you'd like. And same thing over here, add 5 first. We have negative 4x is less than 11. And then divide by negative 4, just like the other one. We have to flip our symbol. Our answer is negative here. 4 goes into 11 2 times. That is 8. It'll be 3 left over, 3/4 left over. Or you can put 0.75. And then I just have to graph this. So negative 2 3/4 is the least. 1/4 would be the greatest. Both of these symbols are open. And if you want to look, right here I had less than, or actually I should look when the absolute value is by itself. Less than gives me and, with 1/4 pointing to the left, and negative 2 3/4 pointing to the right. Alright, next, let's take a look. We need to clean up our bathroom or get rid of everything outside of our shower. So first, get rid of your addition and subtraction. So I'm going to add 8. So we have 3, and then absolute value of whatever's in there. 8 plus 3 is 11, so we have 21. And what do I have inside there? I really have 5m minus 6. But our absolute value is not by itself yet, so let's get rid of that multiplying by 3, so we need to divide by 3. You cannot distribute. These are not parentheses. So we have the absolute value of 5m minus 6, which is less than or equal to 7. Now that we have the absolute value by itself, our shower, whatever we put in the shower has to come out clean. So we could put in a negative or a positive. So we need to set 1 equal to the positive and set 1 equation with the negative. But if we're going to put the negative, we have to flip our inequality. So draw your line down. Get rid of addition and subtraction first. Add 6. If I'm going too quick, please make sure to pause the video. And then we have more negatives is a negative 1. And then last, the opposite of multiplying by 5 is dividing by 5. So that gives us a negative 1/5. On the other side, same thing, add 6. We have 5m. 6 plus 7 is 13. And then divide by 5. M is less than or equal to, well, 13 divided by 5 is not going to be a nice number. 5 goes into 13 2 times, that gives us 10. And there's 3 left over, so 3/5. Or if you want to put as a decimal, 0.6. And then graph it on your number line. Negative 1/5 would be the least. 2 3/5 would be the greatest. These are both closed circles because of the equal to. At negative 1/5 pointing to the right, at 2 3/5 pointing to the left, less than. And double check. When we had our absolute value by itself, less than is an and symbol, and that's what we have, pointing together. Here are 2 more. I would suggest you trying these 2 on your own to check to make sure that you can prove to me that you know how to do these correctly. So first, I'm not distributing. This is multiply, so I need to divide by negative 2. I divided by a negative, so my sign flips. And I have now a positive 4. And here, I have the absolute value of 4x plus 3. So now that our absolute value is by itself, we can write 2 inequalities. One just like it is, 4x plus 3 is greater than 4. Or this whole thing could be equal to a negative, so we have 4x plus 3 and a negative 4, but we have to flip our inequality. So solving this, get rid of addition and subtraction first. We have 4x is less than, these are all negatives, a negative 7. And then divide by 4. I know it's going to be a negative. 4 goes into 7 one time, and there would be 3 parts left over, 3/4. Or you can do 1.75, that's fine. Subtract 3 on this side as well. 4x is greater than 1. And divide by 4. 1/4 or 0.25. And then on our number line, our negative is the least, negative 1 3/4. And here we have 1/4. Both of these are open circles. And be careful, we can't look here at our original. We have to look what our absolute value is by itself to see if we did our graphing right. This is greater, meaning our arrows are pointing apart, and they are greater and to the right here. Perfect. Last one, like this. First we have to get rid of addition and subtraction, so I'm going to add 15. So we have 2, and then the absolute value of something is less than 10. So inside there we really have 3w plus 8. That 3w plus 8 is not by itself yet, so we need to get rid of that 2. We're going to divide by 2. And we have the absolute value of 3w plus 8 is less than 5. Now that our absolute value is by itself, we know that whatever goes in here could be equal to 5 or negative 5. So let's write both options. 3w plus 8 is less than 5, and 3w plus 8, flip the sign, greater than negative 5. So subtract 8. If you want to do all of them at once, go for it. So we have 3w is greater than, and this is a negative 5, all negatives, a negative 13, and then divide by 3. W is greater than, I know it's going to be negative, 3 times 4 gives me 12, and then there's 1 left over, so 1/3, or negative 4.3 repeating. Over here, same thing, we have 3w is less than a negative 3, and then divide by 3. 3 divided by 3 is 1, and it's negative. And we just have to graph it. So negative 4 and 1/3, and negative 1, because that's actually closer to the positives. The bigger negative numbers would be to the left. So both of these are open circles. Greater than would be pointing to the right, and less than would be pointing to the left. And right here you can look less than and inward. Good job. Our last slide is just asking to tell whether the statement is true or false. If it is false, give a counterexample, which is an example that proves why it's wrong in the first place, or an example that would prove it wrong. So if A is a solution of this, absolute value of x plus 3 is greater than 8, then A is also a solution of x plus 3 is greater than 8. So we know that because this has the absolute value, there are going to be 2 answers. So we need to figure out what those 2 answers are going to be, and to say, hey, if we have 2 answers, well then this one answer must also be true. So we have 2 answers that could be true on this side. We could have x plus 3 is greater than 8, or we could have x plus 3, flip your sign, is less than a negative 8. Because no matter what goes in your shower, it could be clean, positive, or it could be dirty, negative. So if we solve these, subtract 3, x is less than, here these are all negatives, a negative 11. And on this side, subtract 3, x would be greater than 5. So if we were to look at our graph here, negative 11, 5, this would be an open circle, this would be an open circle. At 11 we're pointing to the left, and at 5 we're pointing to the right. So this is telling us, here's what they're telling us is happening. This is true. But now they're asking us to tell, well, is this also true? The second part is like a, are we sure? Is A also a solution, or same thing, of x plus 3 is greater than 8? So let's solve this. Subtract 3. X would be greater than 5. Well, here's what they said was true. X, or A, or whatever, has to be less than negative 11 or greater than 5. Well, this one they also got greater than 5. So this one right here, I'm going to do this one in yellow, would be this same part pointing this way. So yes, this is true. because the answers that they said were true here are also true here. All the answers that I could ever have, all the numbers that are greater than 5, like 6, 7, 8, also make this true. Yes, all of these numbers are greater than 5 or less than negative 11. So let's look at the next one. They're telling you if this is true, and guess what? It's almost the same, but we do have to solve it. X plus 3 is less than or equal to 8, and x plus 3, flip the sign, greater than or equal to negative 8. So we're going to solve this just like we did before, really quick, because we really get the same answers, just a different symbol. If I'm going to graph this just like I did before, I have negative 11 and I have 5. Both of these are closed circles this time though, and they're telling me that my answers are pointing together, greater than negative 11 and less than or equal to 5. So here is what they said is true. If A is a solution here, then A is also a solution here, which they're telling you, subtract 3, x is greater than or equal to negative 11. So here we have greater than or equal to negative 11, so here's negative 11. Greater than is to the right, so all the numbers that are greater than this number, negative 11. So let's think about this. If A is a solution of both of these, then that same number, whatever number I pick, also has to be a solution of this. So if I pick the number 2, 2 is a solution here because it fits between the data, and it's a solution here, so 2 works. So we're just going to test some numbers. But I'm going to test some outside here. If I test negative 12, nope, not negative 12, because that's not a solution of these ones here. If I pick the number, for example, like 6, greater than 6, so it's a solution here, x is greater than or equal to negative 11. Well, yeah, 6 is greater than negative 11, but is 6 an answer between these two? And that would be no. This is false, and the number 6 would be a counterexample. It means it's a number that proves this statement to be wrong. So, for example, if I plug in the number 0, well, 0 is between these two, so it works between these two numbers. 0 is greater than negative 11, and 0 is less than 5. 0 is also, if I pick the number 0 here, 0 is greater than or equal to negative 11. That's true, but I need to pick some other numbers. If I pick the number 10, 10 is not less than negative 5, so it doesn't work here. But 10 is greater than or equal to negative 11. So if it works here and not here, that's a counterexample to prove that what they say isn't true. So your homework is out of the book. You have problems 3 through 20. If you finish, put it in the basket, and then you can work on missing work.